And so one of the cool things about using OpenDroneMap is sometimes you get products that you didn't need, weren't expecting because it was necessary in a previous step to get to the thing that you were expecting and the thing that you wanted.
Welcome to another episode of the Mapscaping podcast. My name is Daniel and this is a podcast for the geospatial community. My guest on the show today is Stephen Mather, the co-founder of the OpenDroneMap ecosystem. And today on the podcast, you guessed it, we're going to be talking about OpenDroneMap. So during the conversation, we don't just talk about OpenDroneMap. The conversation moves on and we talk about photogrammetry in general, some of the do's and don'ts, some of the things that you might want to think about, some of the challenges around it, some really interesting use cases that you might not have thought of before. I guess my point is here is we cover a fair bit of ground during the next 30 to 40 minutes. So I really hope you enjoy it. And without further ado, let's dive into the interview. Hi, Stephen. Welcome to the podcast. Really appreciate getting to talk to you today. I've been looking forward to this for a while. Today, we're going to be talking about OpenDroneMap, which is a pretty amazing piece of software. But I think before we get there, perhaps you could just introduce yourself to the audience and maybe give us a brief understanding of how you got involved in geospatial and perhaps where you are today in terms of your career.
So, my name is Stephen Mather. I am co-founder of the OpenDroneMap ecosystem. I think for a while, we sort of said that I was the founder of OpenDroneMap, but most of the projects have actually been developed by my partner and friend, Piero Tofanin. And I guess sort of at the outset, I was interested in the intersection of biology problems and geography problems. I got into GIS in college and never really left. So as far as open source geospatial, I've kind of been doing stuff for a while, but really the change for that started when about 13 years ago, I started working for Cleveland Metro Parks as their GIS manager, and they needed a program built. It was really the opportunity at that point to build that around open source geospatial software, which had reached that threshold where you could say, yeah, we can deploy a server, we can, get these things done. And we made that transition from a closed source ecosystem to an open source ecosystem and did that much more than we otherwise could have done, which was pretty interesting. During that time, then I started OpenDroneMap as a project to sort of scratch an itch that we had, started talking about it with the world. Other folks showed up, including Dakota Benjamin, Piero Tofanin, and a whole range of all the various contributors since. So I started to go around and talk about it, talk to people about what the opportunity was, and the rest is history. It's been a really fun journey.
Well, as I'm sure that the listeners will discover during this conversation, OpenDroneMap is a pretty amazing piece of software. And maybe we should start there. What is it? There's a little bit in the name there that might give us a hint, but I'd be really interested in hearing your description of OpenDroneMap.
Yeah, the Twitter account has been joking a couple months back, and I say that as though I wasn't the person behind the keyboard. It's an increasingly poorly named project because all projects start with a particular purpose and then sort of grow and do other things, which is pretty interesting. But the core part of that is the idea that you could take photos from a drone and turn them into mapping products, whether that's an orthophoto, one seamless orthophoto, or whether that's an elevation model, point cloud, 3D mesh, etc. Under the hood, the basic photogrammetry library is OpenXFM from Mapillary / they've now been sucked into the Facebook world. And so it's also good at doing other things. So we can use it to scan the world, not just using drones, but using commodity cameras and things on the ground and all sorts of interesting things. So there's lots of ways in which we can capture that geographic data, but it started with drones because drones are fun.
Yeah, and because drone is in the title, let's stick with that as a platform. Can you give me an idea of what the workflow might look like? Now, I don't personally have a drone. I've never done any drone mapping, but I'm assuming we go out, maybe we put down some ground control points, we have a flight plan. Hey, drone, please fly up and down here, capture some images, and then we put it into the software. But maybe you could put a few more words around that and sort of give us an idea of what that workflow would actually look like.
To get started, you get yourself a drone, you get yourself some flight planning software, and you go and fly. And so we see lots of different data sets and lots of different use cases, but that's at the core. And the cool thing about the tools, the flight planning tools that allow you to fly these routes is you can say, I want to draw a polygon this area. I want it to have this much overlap between the photos because I'm trying to do it quickly, or this much more overlap between the photos because I want to get a really good 3D sense of what's happening in that scene. And then you fly the drone. Hopefully everything goes okay. You celebrate when it lands because that's the best time, when it's on the ground safely after a flight. That's when my heart, stops pittering, and I'm happy as can be. And then you take that data and you put it into the computer and you process it into geographic products. Now, there's some other pieces to that, right? So maybe you have ground control points if you're fancy. Maybe you just use the flight information from the drone, which probably has GPS built in. That's probably the simpler way to go. And OpenDroneMap does the rest. So if the geographic information is embedded in the images, or you have ground control points, or both, then you're going to get something in the real world. You're going to get something. You're going to get a map in the world displayed, integrated in the rest of everything else that everyone's capturing, and it looks fantastic and it's a lot of fun. And it feels really satisfying. Like, drone flying is fun, but there's something really satisfying about this sort of deep rabbit hole of, hey, what are all the things that we can map? How do we map the world one pixel at a time?
Just out of curiosity, does OpenDroneMap treat all images as being equal, or does it go through and saying, oh, this one was slightly off for whatever reason, and pull it out and not use it? Because we've got that certain amount of overlap, or at least I am assuming we should have a certain amount of overlap built into our flight plan. So does it treat every image as being equal, or does it filter as it goes?
There's two parts to that. There's a stage at which you are matching the images and deciding how related they are. And that's sort of a stage in which you could throw out some images that maybe they were too blurry, and so they didn't match with anything else. Or maybe it was the photo from the ground of you staring at the camera and not actually of the scene that you were trying to capture. And there's no way to match that in, and it doesn't make any sense to match that in. That gets thrown out. And then further down the line, when it's trying to create that blended version of it, the OpenMVS, which is the underlying library, makes the choice as to what the best possible image is for any given location based on a few different criteria, including how close was the camera to that location? How direct was that? Was that like a straight-on photo, or a straight-on portion of the photo, or was that sort of off towards the blurry edge of the photo, et cetera, et cetera? So those decisions are sort of made both at the beginning of the pipeline and near the end of the pipeline, when everything is sort of blended together.
You talked about a few different model types that we can get out of this process, and I think a couple of them were, a mesh and a point cloud. What other models can we get out of, or can we create using OpenDroneMap? And I guess the follow-on question from that is, what can we do with those different models?
There are a few things that come out of OpenDroneMap, and there's a few steps in the chain, and those, like, they're all sort of, one sort of leads to the other. And so one of the cool things about using OpenDroneMap is sometimes you get products that you didn't need, weren't expecting, because it was necessary in a previous step to get to the thing that you were expecting and the thing that you wanted. So one of the biggest questions we get is, hey, all I want is the ortho photo. Why am I doing all this complicated 3D stuff? And so we've done some changes to the tooling which allow you to skip some of the 3D stuff. But generally speaking, your steps are to sort of match all the photos. From that, then feed that into a structure for motion algorithm, which then tries to figure out where all those photos are relative to each other. And I'm simplifying here, and then from there, then we match all the pixels and all the photos to each other so that we get a real detailed 3D sense of the scene. And then from there, we can create three-dimensional mesh that we then texture. And then from there, we get to create an ortho photo, or from that point cloud, we step through and we create a digital terrain model or a digital surface model.
Can I do any analytics based on those models in OpenDroneMap, or do I need to export them out to something else?
A little of both. I mean, so OpenDroneMap at its core is the command line tool. It's been wrapped so it's got a nice interface thanks to projects like, Poodle and Twine. So a certain amount of analysis is done in there, and sometimes you get to the uncanny edge where you don't want to do everything in a web interface, but you actually want to pull that into a more sophisticated tool. So if you're doing agricultural analysis, because there are some really great browser-based tools for doing indices on the fly, there's some great indices for you already built in. If you're doing some rudimentary machine learning-based classification where you're trying to tell what's ground and what's not ground, those are baked in. If you're looking to take it further and you want to, you want to do all the things that are available in fully functional GIS tools, then the idea is that you take those products and then you do the further processing beyond. But WebODM itself, which is really that beautiful front end, is plugin based. So a lot of folks have been able to do some interesting things where they build new plugins for it in order to do things that it currently can't do. So if you need to scratch that itch, that's the place to do it inside OpenDroneMap.
So I feel like maybe we've jumped over the architecture side of this as well. But perhaps you could talk about that just for a second, because you talked about it being a command line tool, but is it?
I guess I'm sort of thinking a bit historically there, and that's really the reason that Piero showed up and added to the ecosystem, because he was out there. He had a drone. He's a web developer doing contracts with people and doing cool work and running his own little business and doing really well. And bought a drone and flew a drone. And after flying the drone for long enough, he got bored. He's like, "What else can I do with this? Oh, I can make maps with it. Well, what open source tools exist for doing that? OpenDroneMap. It's command line based. Well, I don't mind that, but it's terrible for everyone else." And so he wrapped the whole tool in a series of interfaces and in an ecosystem that really allows you to have a really nice user experience. So part of that is Node ODM, which is really sort of a programmer's dream in that it wraps all the functionality of that core tool in an API, essentially. It doesn't do any of the fancy things that protect the data, like authentication, et cetera. It doesn't handle any of that. That's really meant to be sort of that private web API. And then you go one level up from that, and we've got a few different tools, but probably the most important one in the ecosystem, the one that people are most familiar with, is WebODM, which then allows you to upload images, process them, view the outputs, download them. If you've got this on a publicly hosted instance, you can very easily send a share link to people. And then he's gone on to build a whole suite of tools to make it easier for people, basically lowering the barrier of use. So basically creating tools where, like WebODM.net, where people can use his processing nodes to get work done for a small fee, and use the things that he builds and maintains, or use that as a starting place and then build their own when the time comes.
I just want to make sure that I've understood this. So what we're talking about is that client server architecture, and then we also have the opportunity to run this on hosted instances of OpenDroneMap. Is that correct?
That's right. Yep.
Why was that client server architecture a good choice for OpenDroneMap? Why not go for a desktop version?
That's a good question. The desktop ecosystem has been slow to come around. As far as what choices Piero made in development, I think he was thinking about, how do you create something that has a lower barrier to entry without completely rebuilding the entire tooling, right? So OpenSFM really only runs on Linux machines. We could have built a desktop tool around that, but it still would have only run on Linux machines. But if you treat it as something deployed to the web, then you've got anybody who can get on the web that can deal with it. And it was, I think it was it was literally March of 2020. I'm flying back from Rwanda in the midst of all the borders closing during the pandemic, and I realized that one of my jobs failed. I pull it up on my phone in an airport. I go in and I make some changes. I tweak the settings and I get it running again. Deploying to the web means that it's really available everywhere. Now, that said, Piero's done a lot of work. Piero and his team have done a lot of work recently to solve the problem of deploying to Windows, so that the Windows installer is no longer dependent on Docker and doesn't have all the sort of limitations of the Docker ecosystem. So going through bit by bit, looking at each of the libraries and figuring out exactly how they need to be ported. And that process is 95% of the way there. And then we're working through all the remaining sort of the rough edges, figuring out how to make that even better.
So just as a quick recap here for the listeners, we've got this amazing piece of software. It's open source. It's a client server architecture. If we're talking about capturing images using a drone, it doesn't really care if we have ground control points or metadata. It'll kind of figure it out for us. It'll create all these products along the processing journey. And then it also gives us opportunities to do some analytics in the software itself. But if we want to export it to other systems and sort of continue looking at our data, that's fine as well. When you think about capturing data with this, what kind of scenes, what kind of objects should we not be using or not be trying to capture and create models of based on photogrammetry?
So the classic difficult problem in photogrammetry tends to be things which are specular, things like cars that are, that were just washed. If it's like my car, it'll be fine because it's covered in dust and pollen, but shiny buildings, mirrors, pretty much anything that's sort of a specular reflector that has that, that shininess to it is going to be more difficult to reconstruct, more difficult to impossible, depending on what that is. Fortunately, most things that are outside tend to tend to, degrade a little bit in the sunlight, tend to get dust on them, tend to not be shiny. So aside from like a mirrored glass covered skyscraper, most things are easily reconstructible that are in the out of doors. So usually when people run into problems, it's that, they've got some shiny plastic toy that they're trying to do, or something that's relatively featureless. The other challenging places are things with repeating patterns. So a really common theme that we see in the forums is, I flew the soybean field and it doesn't reconstruct even though I've got enough overlap. And the reality is that soybean field is planted so evenly that it's difficult to discern one set of rows from another. And really the trick to repeating patterns is, at some scale, they aren't really repeating. At some scale, there is differentiation. So either you need to fly lower, you need to get closer to your object of interest, or you need to go higher. That's really the trick. And, there's not really the best, like you kind of guess at it and you try it and you talk to folks who have done it before. Oh gosh, over soybean fields, I always fly, 45 meters or whatever that sort of general rule is that someone's discovered. And if that doesn't work, then I go to 65 meters or whatever that is. I guess those are the three categories of things that are difficult to reconstruct: shiny things, things without features, and things with repeating features. Shiny things you can still reconstruct as long as they're not a mirror surface. Water tends to be one of the really deep and common challenges. Featureless things, there's not much you can do with. And repeating patterns, you just need to change your scale in order to change how that repeat looks to the algorithm.
When we think about changing our scale, if we again use the idea of flying a drone across a soybean field, should we be changing the scale in that one flight, or should we be flying at different flight plans, I guess, each with at a different scale, a different distance from the ground?
I think in principle, it's useful if we want to get a certain level of detail. Say we really want the detail that we get at 15 meters, but the repeating pattern that's too low to be able to discern what that repeating pattern is. So we also fly it at 40 meters or 50 meters. I think there's a huge body of research to do on how best to optimize those multiple scales and how best to do the matching between them. And it's a matter of someone sort of taking the charge and figuring out really what works. So shooting at multiple heights, so it gives you the opportunity to potentially extract extra detail, but also take advantage of that larger synopsis view to help you discern how things match and what makes sense. But the challenge in doing that is getting, you've gone from a problem of you've got one knob to twist, right? Like how much overlap do you have between your images, to several knobs to twist. So if you're flying at two heights, then what are those two heights? How do they interrelate for your object of interest? So that whole space of possibilities is much larger. And I think there's a lot more space for people to explore and create sets of recommendations for that.
So just sticking with the idea of playing around those parameters there, can I do that in OpenDroneMap? Or is it just, it uses the same process every time to try and reconstruct the scene? And I guess what I'm thinking here, let's say I capture a field, I capture a building, I capture some sort of object. I'm not quite happy with the reconstruction. Do I tweak parameters in OpenDroneMap, run the process again, or do I go out and recapture the object or scene?
I would say the first thing to do is definitely to change parameters in the software. So we tend, some development is like nuisance based, right? So by default, the settings in OpenDroneMap are meant to not take all the memory in your machine and crash no matter what you do, right? So there's certain knobs that can be turned up, both as far as, okay, I flew this with X amount of overlap, and I want to extract, instead of extracting by default 8,000 features per image, I want to extract 40,000 features per image to really maximize the capacity to perform those matches. And I don't mind the additional processing time, and I don't mind that it takes a little bit more memory. So there are plenty of knobs in the software for sort of optimizing a flight that you've already done. And the forum is a great place to sort of go, okay, here's my set of images, or here's a subset of my images that I feel comfortable sharing. Here's the processing parameters. Here's the results I'm getting. I'm not real happy with them. What can we do? And almost immediately, Brett will hop on and say, hey, great, here, try this, and this, which is a really nice thing because you've got this community of users that have experience with these data sets, have played around with a bunch of different ways, and know which knobs are most likely to get you to where you want to be. And sometimes you get to the point where you've twisted all the knobs and you're like, still not good enough. And you're like, all right, it's time to refly. So, particularly if you're in sort of the pilot phase and you're trying to figure out what'll work and what you want, a lot of times you need to plan for extra flights. I'm the person who has a tendency to fly too many images in a given flight and then have regrets about the fact that I need to figure out which ones to throw away. But we each have our own tendencies there.
How important is that temporal resolution there in terms of these perhaps different flights that you undertake?
Less so than I thought. Well, so it depends on what you're doing flights over. If it's something that changes a lot, temporal resolution matters a lot. So if you're talking about like someplace where there's water and a shore, or it's vegetation and it's not midsummer, but it's at a transition point, spring or autumn, or a transition from rainy season to dry season, or whatever that transition point is. So that temporal resolution is really dependent upon how much there are changes that are happening. So that's one aspect of it. Are the objects going to be there when you come back? Can you simply add to the pictures that you have, or do you need to capture fresh, a complete new set? And then the other thing to worry about, and this has been less of a challenge than I would have expected, and that is the lighting. Are you capturing at a similar time of day? Did you capture it when it was sunny and now you're capturing it when it's cloudy? It will make a difference and it will make it harder. But a lot of times, if you have to sort of stitch those images together and they don't 100% match the same lighting conditions, it'll be okay.
That's interesting. I really thought that lighting, depending on what time of the day you captured the scene, I thought that would have a much, much, much bigger impact than what you're suggesting. So up until now, we've been talking about capturing images, scenes, objects using drones. What if I have my cell phone? Or what if I take pictures with my cell phone or perhaps a video? Can I do anything with those two kinds of data?
There's a lot of really cool things you do if you're not flying a drone. So one of the things I really like is that, well, I actually, for a workshop, I actually took pictures of my kid's Lego table in a drone-like pattern and reconstructed an OpenDroneMap, and it looks fantastic. It's just this really cool snapshot in time 3D model of everything they had built on that Lego table. But it doesn't have to be that kind of pattern. So I've taken 360 cameras and walked through my house. I've walked through other people's apartments and done full 3D reconstructions of that place. I live in a house that was built in the late 1920s. The bathroom is largely original, and the exterior wall for the shower shows its age. So we're actually working on replacing the shower surround. And my kids were really interested in they didn't want to see any change. They didn't want to see the bathroom go away. This is the bathroom they've known their whole lives. So we actually have a full 3D model of that bathroom. Basically walked around with a 360 camera, captured a bunch of photos, reconstructed that in 3D. And so we've kind of got a stamp in time for what that bathroom looks like. And then I've done some interesting things recently with taking cameras and putting them inside guitars. One of the challenges with musical instruments and documenting musical instruments is like, how do you take the measurements in a non-destructive way? So you got I don't have anything like this, but say you had like an original Martin or Gibson or some 1860s Spanish guitar made by Torres, and you wanted to really understand what makes that thing tick. What are the measure all the things in it, really understand how that thing works and how to create something that works in a similar fashion, that feels similar, that sounds similar. Nowadays, there's lots of tools at your disposal. You can put calipers in there. You can measure directly. There are people who are scanning these things with medical scanners. So there's just like all sorts of levels of, what's your budget and what's your time? How do you want to understand this thing better? But one of the really inexpensive ways we can do that is actually put small cameras in there and basically do a photogrammetric scan of the interior of musical instruments. So I've been playing around a bit with that, building smaller and smaller cameras, figuring out what's possible. And more news on that later, but it's working pretty well. It's pretty interesting. It is a low cost, high impact way to really get these fantastic measurements of, in my case, a cheap Alvarez from the 70s, but in other people's cases, maybe some really interesting instruments that we want to understand better.
I think it's a really interesting use case, but I'd be curious to know how you deal with some of the problems around the perhaps lack of texture or the repeating pattern. Because I'm thinking that you're quite close to these instruments when you're taking the images of them. How does the software deal with that?
Well, so far so good. One of the challenges that I've had is sort of the shininess of the exterior. So when you're scanning the exterior, You got to get your lighting nice and flat and minimize the reflections. As far as the texture on the interior, I think focus is one of the challenges. So making sure that given the low light conditions, that the depth of field is enough that all the things that you want to be in focus are in focus. So that's one of the things that will need to be worked through. And texture is we're probably at an advantage as far as texture, just because wood reconstructs fantastically. You've got repeating patterns, but they're not exactly repeating because it's an organic substance. It's non-specular, especially inside the instrument, so it's like super diffuse. So we get really, really nice feature extraction from that. But there's a lot more play to do. I'm sure there's like occlusions are going to be a challenge as well. How do you light the thing so that you can see everything without blowing out those textures? So I'll know more as I do more.
Playing around with the lighting and the shadows, that must be really interesting. Obviously, this is something we can't control on the outside. Can this make a huge difference to the end result, to the reconstructions?
Yes. So I did some exterior reconstructions this is late 2019, and it was in December in my house with poor lighting. So I kind of found some of the limits there. If you've got really low light, with a digital camera, and if there's relatively high contrast, so if the lighting is relatively not as even as you can get it, then those darker areas, those shadow areas, tend to have a lot of noise in them, tend to not reconstruct, tend to not you tend to not be able to extract features from them. For the interior, this becomes an interesting problem because inherently the interior of a stringed musical instrument is dark. So maybe the solution is to put the whole instrument on a cool light source and have that light come through the instrument. Or maybe the plan is to just light it really well with direct lighting inside the instrument. So those are the things that need played with, figure out what really works best and what minimizes the amount of noise in the final result.
So I guess in terms of what we think about as perhaps of normal photography, I guess this is the problem that a flash is solving. Could you imagine a time where we start seeing flashes on drones, for example, sort of built into the camera, where we're artificially lighting the scene in order to create better reconstructions down the road based on the images we're capturing?
Well, yes, but this will be a sort of a quarter turn in that lidar scanning on drones is becoming both more feasible and more affordable, where you're not trying to just get the three-dimensional information from the photogrammetry, but you can pair that with a lidar scan. Now, there are a few problems there. Lidar is compared to just a commodity camera. Lidar is actually there's a lot of power consumption involved in that. Another challenge that you have is orientation, position, the IMU problems. Good IMUs are really expensive. So the units are still pretty expensive relative to other things, but those costs are coming down and it's definitely a space to watch. And then as part of that, like I don't know what the timeline is on this. I know Howard Butler a few years ago was talking about LiDAR scanners moving from spinning mirrors to arrays of photon captures, where you're sort of blurring the space between the camera and a LiDAR device, and you're getting arrays of LiDAR responses rather than individual points. And that really kind of changes the game and becomes the next generation of LiDAR scanners that scan essentially. I don't even know what to say about it. Like every time I think about it, it blows my mind enough that I'm not sure how to think about what reality capture looks like under those conditions. So there's a lot that's going to happen there, and I don't know what the timelines are. I think a few years ago, it's talking about 5 to 10 years. So we're getting close to some of those timelines.
That would be amazing. Hey, I'm assuming what would happen there, like in my humble little mind here, is that we would be collecting a 3D model of the scene and also adding that texture immediately with the image. Is that the right way to think about that?
Yeah, that's definitely the right way to think about that. A lot of that's happening now with scanners, but that power consumption question is still one of the very real challenges. The nice thing about LiDAR relative to photogrammetry is that if you want to see those ground points, if you want to see past the vegetation, LiDAR is still really it's the only complete way to go. Like it's the only solution that completely solves that problem of getting through all the gaps and getting to that bottom layer.
So if we try and bring this, we've been talking about a few different data sources now and a few different data capture methods. And if we try and bring this back to OpenDroneMap, If I had a LiDAR model already, could I put that in OpenDroneMap and then use that to correct my reconstructed scene based on photogrammetry?
You can. The workflow right now would be best described as ugly. So we've been kind of asking people, and this is, I guess I put this sort of out to the map scoping community. Like, if you've got a data set where you captured LiDAR with photogrammetry from, particularly from a drone, gosh, we'd love to see that. Because figuring out what that workflow looks like to make that easy for folks to do is something we're interested in solving. We get questions about that a lot, but we very rarely get data sets that we can sort of plug and play and play with. So I think in the last couple weeks, Hiro played with the data set from someone in the community, and offhand, I can't remember who that was. They had a LiDAR scan and they had photogrammetry, and they said, hey, can I combine these things? And the short answer is, yes, you can. And the long answer is, right now it's difficult. So that's certainly something we're interested in playing with and getting better at.
Yeah, so I guess that kind of leads nicely on to the question about what can we expect to see from OpenDroneMap in the future? Or maybe a better question would be, what do you think is missing in the software today?
I mean, LiDAR integration is definitely one of those things. As far as things that I know, so I have been colossally bad at predicting what's next for OpenDroneMap for the entire time that I've worked on the project, which is actually really says a lot about the vibrancy of the community, and really says a lot about sort of the multiple directions that people are going at the same time and bringing back to that ecosystem. So it's really an asset. But I'll say, this is what's happening next. And I said it with such confidence the first few years. And now I sort of like, well, these are the things I know are funded, and these are the things I'd like to see happen. And some of those things get done, and some of those things take a few more years. But LiDAR integration is definitely something to be interesting. There's a lot more work to do on the agricultural side as far as sensor integration. Every multispectral sensor out there released sometimes by the same company as the last one, sometimes by a different company. Every one of them has a different standard for how the data are structured. And each of those need, sort of a high touch. They need a good example data set. So if you've got a sensor you want an OpenDroneMap, sharing that sample data set is an important thing to do. And then there are sort of the bigger themes of like, how do we structure ourselves to really be around for the longer term? Open source projects, they're not easy. There's a reason why the proprietary models have their successes and challenges. One of the challenges there is you never know when they're going to turn up the knobs on the cost or get acquired by someone else or otherwise sort of blip out of existence. But on the open source side, we have all the challenges of maintaining the community and keeping people engaged and funding things that need to get done. So we're really giving some deep thought to, what does the structure of the project look like? How do we make sure that structure informs the next 5, 10, 15 years of OpenDroneMap? How do we help create predictable feature advancement? So how do we make this question easier to answer for our users in the cases for the stuff, that some of the core folks actually have a little bit, a modicum of control over and funding for? And then how do we make sure that we're continuing to provide an environment where someone tries it out, does some stuff, gets frustrated, and knows where to go to help figure out what those next steps are. To that end, Piero actually hired Brett Carlock, Saijin Naib, as the IT specialist and community manager out of UAV for Geo to really do what he was doing already. He was spending a lot of time on the community forums helping people out. So a lot more of his time can be dedicated to that. And then making sure that we're contributing to and collaborating with our upstream libraries, whether that's OpenSFM or OpenMVS, Poodle, Entwine, Goodle, Grass, MVS texturing, etc. Like figuring out what works for us, figuring out what's more general, and pushing that upstream so that those projects do better as well.
We've had a couple of conversations now, and you're a really interesting, engaging, and incredibly intelligent guy. What do you tell people you do when you meet them at parties? When we can go to parties again? How do you? What do you say?
Had we had this conversation 2 months ago, I would have said, well, I'm the GIS manager for Cleveland Metro Parks, and I manage a team of folks to do cool geospatial problems for the parks and for conservation globally. And I also lead this project, OpenDroneMap. And actually, my current daily job is as a systems administrator, and then OpenDroneMap is this thing that I do on the side now. So I don't know what I would tell people now. I'm really excited to do the work that I'm doing. Like, this admin work is really in support of research. So it's really to work with really cool, interesting, engaging people at Oberlin College who are doing fantastic, globally impactful research. And I get to be a part of that and sort of making their jobs easier to do that. And then I get to continue to work in the OpenDroneMap ecosystem, talking to folks like you, driving that larger conversation, and then also doing side projects here and there where I'm helping people process data. Someone once teasingly said, "This guy doesn't sit in a cubicle, does he?" And that's definitely true. I don't fit in a neat box, but I like to solve interesting problems with people who also like to solve interesting problems. And most of those are geographic, and the ones that aren't geographic are still technical.
When you think about geospatial, is there anything within the community that you've seen that's made you change your mind recently? Is there anything out there that you think there's like, that thing there, that changes everything?
The work that's being done by Lutris right now and Hobu and sort of the ecosystem of point cloud folks to integrate point clouds into QGIS is unbelievable. The first cut at that, I was immediately using in a project, because there's nothing quite like dropping your point cloud right into the map and verifying and digitizing right on top of that. As far as workflow, that really changes things substantially relative to anything that I've seen before. And now I just saw a couple days ago on LinkedIn that they're working on the remote point clouds problem. So how do you not just point that to a local resource, but how do you point that to all the point clouds for the country of Denmark, or whatever that massive point cloud data set is. So that changes a lot of things, because the tighter we integrate the tools in ways that are flexible, if that makes any sense, the lower the friction is. Suddenly things that we didn't think were possible become possible. So when point clouds and raster got added to PostGIS and PostgreSQL, it seemed like a silly and trivial thing until people started to use them and realized that having the data that close meant that you could do things that you couldn't do before. Getting point clouds in a really usable fashion into QGIS is one of those things that will change how people do these things. And the timing's great, because we've got tools like OpenDroneMap, we've got tools like all the things that are coming out of the platforms, the Apples, the Facebooks, the Googles, where the generation of this data is accelerating, but we don't always have great ways to consume that and combine that with other data sets. And so projects like what's happening in the QGIS ecosystem with point clouds really, really changes things.
Stephen, this feels like a really sort of great place to kind of round off the conversation. So I just want to say thank you so much for doing this with me. I've been really looking forward to this conversation. I think it's an absolutely amazing project that you're working on, that you're building with the community there. Yeah, I'm really grateful for all your work and for your effort. I think it's amazing what you've built. Before I let you go, though, where can the listeners go if they want to reach out to you, or if they want to learn more about OpenDroneMap? Can you point them to any sort of specific URLs or accounts that they can follow?
Yeah, absolutely. So there's the Twitter account is at OpenDroneMap. OpenDroneMap.org is a fantastic place to start. That'll get you pointed in the direction of downloads, installers, etc. Docs.opendronemap.org is where all the docs are at, and that's a constantly evolving and added to ecosystem, translated into, I don't know, at this point, 6-7 languages. And community.opendronemap.org is really where all the conversation takes place.
Thanks again, Stephen. I really appreciate your time.
Awesome. I really appreciate it.
So I really hope you enjoyed that conversation with Stephen about OpenDroneMap. As I mentioned at the start, we covered a fair bit of ground in that episode, so I hope that you found something useful in there. Stephen mentioned a bunch of different resources. I'll have links to some of those in the show notes, but I think in general, if you're looking for information on OpenDroneMap, a really, really great place to start is just opendronemap.org. Stephen mentioned a few other projects. One of them was PDAL or Poodle. I recently recorded an episode around that. There'll be links to that in the show notes. And GDAL was another one, or Goodle. And again, recently recorded episode, so I'll put a link to that in the show notes as well to make it a little bit easier for you to find. Towards the end of the conversation, Stephen mentioned some work that's been done in the QGIS environment to help integrate point clouds. QGIS is another topic we've talked about a few times on the podcast. So if you haven't already listened to them, there'll be links to those episodes in the show notes as well. And that's it for another episode of the Mapscaping podcast. Thank you so much for listening all the way to the end. It's much appreciated. As always, you're more than welcome to reach out to me. You can find me on Twitter at Mapscaping, or click the link in the show notes through to my LinkedIn account. I would love to connect with you there. You're also more than welcome to check out our website, mapscaping.com. There's a few other contact details there that you might find helpful. I really hope that you'll take the time to reach out to me to share any feedback or recommendations or perhaps suggestions you might have regarding the podcast. I would love to hear from you. So that's it for this episode. I'll see you again next week. Bye.